For this video, I'm going to show the assembly of the spring-loaded brush holder. This part, we're going to try really hard to keep it in focus this time. This part is one of the 3D printed parts used in the vehicle where strength is not the utmost consideration. This is a fairly complicated part with internal and external features. It includes some things that I've learned over the past year or two that I've been 3D printing parts. One is you can actually make holes that you can screw into by adjusting their diameter based on the screws you're actually using, and by playing with the diameter, making some test pieces, you can get really strong fits to screws so you don't have to embed steel nuts inside. I've done that also. You can do that when you have depth to play with. We've got some pretty decent height here, and we end up putting screws in from that side and from that side. Another thing that I've learned is that features inside a part look really easy, but they can be difficult to get to come out exactly the way you want. It's not that the sizes are that far off. It's that the material that's used to fill those holes and those slots tends to stick to the material to the side of it. And when you go to remove that material in order to start putting it together, you often deform the pieces it attaches to just a little bit. Whenever possible, always oversize your holes. If it's not a strength consideration and there's not location consideration or wall considerations, if you're just going to put a small pass-through in a part like this, make it as big as possible. That allows you to get tools down in and light. This is the part I'm going to be using. I've added some notches in the back for the wire to go into, and we're going to make this part that holds 6 brushes. The brushes are as big as I could find in terms of wire size that was readily available. There are a massive amount of brushes out there. I mean, unbelievable number of brushes. And the wires vary from tiny to reasonable size. This one is, I would say, more on the reasonable size. I wish the wire was heavier, but I guess because they mass manufacture them, they make it as small as they can get away with. This was I think this was about $1.50 a piece. You can have custom brushes or larger brushes that can get up to like $80 or $100 each, right? And one of the other things is I thought about replacing this wire, and I might do that in the future. I'm not quite sure how it's held into the brush, so I'd have to drill it out and reattach a different wire. I can try that. I just don't want to have it come loose, so for now I'm using these brushes. The copper piece was water jet along with the hoops for the brushes. Same piece of copper, and that just made life easier. Springs and screws are complete the parts I need to put this together. There's no particular way to orient the brush itself although the hole in the back, this hole right here, there's a feature on the inside that helps to accommodate the little bump here on the brush. So that goes in. We slide it in, we check to see that it at least moves back and forth a little. And that is the start. The spring loading actually gets loaded from the back and it is adjustable. There are 3 brushes, but there are 4 holes in the copper. 3 of them are going to hold the brush connectors and 1 is going to hold the output wire. Depending upon what kind of steering system you have, you're going to assemble it in one way or another. In this case, the steering motor's on this side, which means that this side needs to be the output of the wires, because if it was this side, it would be too close to the steering motor. This right here is the top, so there is no reason for this to be countersunk too deep. In the end, we're going to end up covering it with either hot glue or make some little 3D printed thing to go over it. And you're going to find that the screws are a little longer than normal, and that's because you want them to have more grip on the nylon/carbon. And tighten it down. Doesn't have to be critically tight. Now you have a brush that goes back and forth, but the length of how much it can move is restricted by the length of the wire lead. The next step here is to drop a spring in, and then we have a 1024 set screw that goes in the back. This is flat, and based on how far you put the set screw in, determines how stiff the spring is. I'm going to repeat that cycle over and over again. For now, I'm just going to do one more on the bottom. Notice that in this case, the slot is much, much deeper on the bottom. And that's because when this sits flat on the aluminum, you don't want the bottom, any of the bolt heads touching the aluminum, or it'll ground the aluminum. So we go put our piece in. Well, these are not exactly loose here. Put the brush in. It's going to go to the same side. the screw in. I could have probably moved these slots a little, be a little better. I think I might have to make a wider slot to accommodate the wire in for both directions. All right, so that's now loose but constrained by the wire. Drop the spring in. Put a 1024 screw in. And that is quite nice. If I run the system and it seems like there's not enough tension, I can tighten the screws up, get a little more tension on these, or force, I should say. If I find that there's too much force, I'm going to have to go with lighter springs. But that's it. That's how I make the brush assembly. And because I'm paranoid, I always do a second fit. And there you have it. Time to finish it off camera. Here's the brush system fully assembled, waiting for I think probably just hot glue will be good enough to put over the top to make sure it doesn't touch the aluminum. Now, one of the things that I know that I'm going to have to do is put this on and spin the steering system, the steering drive, for a while to help put a little bit of curve on these brushes. These flat brushes, when they contact the hoop, the copper hoop, they're going to have a point contact to start, and it's going to take some time and wear to increase that point contact. Actually, it's a line contact, excuse me, to increase the line contact and make it curved. I don't suspect that I'll need nearly the entire brush width. If you look at the cross section of the copper wire compared to the brush, I think you don't need that much. One limitation I know, because this is 3D printed, is these brushes are going to get hot if I push them. If I try and run, I don't know, I'm going to have to test it, but I think if I tried to run 200 amps across these three brushes, my guess is that they would get really hot. And if that happens, the material, 3D printing material, is going to get soft, and then we're going to have all sorts of really bad things happen. So these are likely to be the limiters on how much current I can put to the drive wheels. Have to figure it out as I go.